Welcome to the Mountain Path, the world of finance. This is Ravichandran. This session we will discuss how to price futures options using a black model. So pre-requirements for this session as usual, basics of the derivative options, the payoff, put call parity, as well as option moneyness and option pricing determinants. Let's quickly go into discuss what is a futures options contract. A futures option is the right but not the obligation to enter into a futures contract at a certain price by a certain date. A call futures price is the right to enter into a long futures contract at a certain price. A put futures price is the right to enter into a short futures contract at a certain price. If a call futures option is exercised, the holder acquires the long position in the underlying futures price plus a cash amount equal to the most recent settlement minus the strike price. If a put option futures option is exercised, the holder acquires the short position in the underlying futures contract plus a cash amount equal to the strike price minus the most recent settlement futures price. Put simply, the payoff for a futures call option is nothing but max of ft minus k, 0. ft is nothing but futures price at expiry. K is the strike price. A payoff for a futures put option is max of strike price k minus ft, 0. Important note on expiration. Futures options are referred by the delivery month of the underlying futures contract, not the expiration month of the actual option of the underlying. So what can be the underlying for the futures options? You can have a stock futures, you can price a bond futures option price, you can also have commodity futures option, you can also have bullion metals futures option, you can also have interest rate futures options. So you can calculate option price for varying underlying asset, and that is and different types of derivatives futures. So let's quickly go into the black model. Black model is a mathematical model, is an extension of Black-Scholes option pricing model that includes actually to price futures options. So the black model is actually takes into account the cost of carry and associated with the futures contract, such as interest rates, dividends, and incorporate them into the pricing formula. So the black model assumes that the underlying futures price follow a log normal distribution. It provides a closed form solution for valuing a European style options and futures contract. So European style options can be exercised only at expiration. So as usual, the key inputs for the black model are the underlying futures price, the future strike price, time to expiration, risk-free rate of interest, and the cost of carry. So what can be this formula for calculating the call option and put option using black model to price a futures option? Call option is exponential minus RT. There is nothing but a discounted value of the futures price, so the at time t0 or the forward price at time t0 into n of d1 minus the strike price into n of d2. What is the put option price? Exponential minus RT into strike price into n of minus d2 minus f0 into n of minus d1. Whereas d1 is a log of f0 divided by k plus half the variance into time divided by sigma into square root of time. d2 is nothing but d1 minus sigma into square root of time. There is a slight modification in the block model when compared to Black-Scholes option pricing model. Whenever you just have a look at the d1 calculation, ln of instead of s divided by k plus half the variance plus risk-free rate of interest into time, so we omit, there is no risk-free rate of interest mentioned in the d1 calculations. So there is a small change you have to note down. Let's quickly take down one simple example on how to calculate and a futures option using a European style options. Let's take the model inputs as usual. The forward price of futures price at time t0 is 70. The volatility is 20%. The risk-free rate of interest on a continuous compounding basis 6%, and the time to expiration is 5 by 12, and the strike price we will assume it is 65. Let's quickly go into the option parameters for the black model. So we will get ln of the forward price divided by k plus half the variance into time, that is a numerator. The denominator of d1 is nothing but sigma into square root of the time. The next is calculate d1, that is numerator divided by denominator. Calculate the d2. d2 is nothing but d1 minus sigma into square root of time. Calculate normal distribution of d1, Norm's distribution of d2, then Norm's distribution of minus d1, n of minus d2. Then we straight away go into European call option calculations of a futures option contract. That means we can simply multiply exponential minus RT into F0 into n of d1 and minus the strike price into n of d2, and this gives you an option price of call option of 6.37. The put option price similarly exponential minus RT into strike price into n of minus d2 minus f0 into n of minus d1. So we got 1.49. So we can check the put call parity whether our calculations are correct. So the put call parity equation for a black model is a call plus the present value of k is equal to put plus the forward price into exponential minus RT. So we get both this left hand side and the right hand side is equal to 69.76. So one important thing that when we discuss put call parity, we initially discuss for a simple non-dividend paying stock, we say call plus present value of strike price is equal to put plus current stock price. If it is an index that gives using a yield calculation, call plus present value of k is equal to put plus a stock price into exponential minus q into t. If we have calculated option pricing for a currency option, and call plus present value of k and is equal to, that is we have to use the domestic rate of interest here plus put plus a stock into exponential minus a foreign currency rate into time. So the put call parity for a European option and slight modification as we modify the model. So this ends this session. In the next session we will discuss implied volatility calculations using and a Black-Scholes option pricing model. Thank you very much.